Some of the most incredible technologies ever developed by humanity were designed for space travel. Two of these remarkable innovations are the Voyager spacecrafts. They continue to amaze us even after decades of non-stop discovery. Although both spacecrafts are on their separate missions, Voyager 1 has just detected a monster object hurtling through space. What was unexpectedly found traveling across space near the Voyager spacecrafts? How will this affect Voyager's future space exploration? And why does this newest discovery have scientists scrambling for answers? Let's find out. As part of the Voyager program, NASA launched Voyager 1 on September 5, 1977, intending to study the outer solar system and the interstellar region beyond the Sun's heliosphere. Voyager 1 launched 16 days after its twin, Voyager 2, and entered interstellar space as the first artificial object to do so. Its purpose is NASA's mission to explore the furthest reaches of space and the deeper levels of our solar system. Voyager 1 has been traveling for more than 45 years and is now the object created by humans that is the farthest distance from the planet, estimated to be 14 billion miles away. Despite this, light from the Voyager 1 spacecraft only needs 22 hours, 2 minutes, and 54 seconds to reach Earth. So we are still able to collect new data from the spacecraft despite its far reach into the cosmos. Voyager 1 was launched after Voyager 2 because of a quicker path. It left the asteroid belt before its twin on December 15, 1977, and in April 1978, while it was around 165 million miles, 265 million kilometers, from the planet, it started its Jovian imaging mission. Jupiter's atmosphere seemed more tumultuous in images returned than during the Pioneer flybys from prior years. Voyager 1 started taking pictures on January 30, 1979, and continued doing so every 96 seconds for 100 hours. This resulted in a color time-lapse video that showed 10 revolutions of Jupiter. The spacecraft entered the Jovian moon system on February 10, 1979, and in early March, it found a narrow ring around Jupiter that had never been seen before. This discovery alone was a major milestone for the NASA crew back on Earth. Then, on March 5, 1979, Voyager 1 made its closest proximity to Jupiter at about 174,000 miles, 280,000 kilometers. Subsequently, it passed by several of Jupiter's moons, including Amalthea, Io, Europa, Ganymede, and Callisto, in that order, to send back stunning images of their landscapes and reveal entirely new worlds to planetary scientists. One of the most intriguing discoveries was made about the planetary body Io, where photos revealed a strange yellow, orange, and brown globe with at least 8 active volcanoes spouting material into space, making it one of the most geologically active planets in the solar system. The existence of active volcanoes raised the possibility that the oxygen and sulfur in space may be due to sulfur dioxide-rich volcanic plumes from Io. Thebe and Métis, 2 more moons, were found by the spacecraft. Voyager 1 made its first course adjustment after its encounter with Jupiter on April 9, 1979, in order to be ready for its rendezvous with Saturn on October 10, 1979. A second adjustment ensured the spacecraft wouldn't collide with Saturn's moon Titan. In November 1979, it made a flyby of the Saturn system, which was just as stunning as the first time. 5 new moons were discovered by Voyager 1, along with a ring system with thousands of bands, wedge-shaped transient clouds of minute particles in the B ring that were dubbed spokes, a new ring called the G ring, and shepherding satellites on either side of the F ring that maintained the ring's sharp edges. The spacecraft captured images of Titan, Mimas, Enceladus, Dione, and Rhea during its approach to Saturn. The incoming data suggested that all the moons were mainly water ice. Titan was the target that Voyager 1 passed by on November 12, 1979, at around 2,500 miles, 4,000 kilometers. Images revealed a dense atmosphere entirely obscuring the surface. The probe discovered that nitrogen comprised about 90% of the moon's atmosphere. At the surface, there were 1.6 atmospheres of pressure and a temperature of minus 292 degrees Fahrenheit, minus 180 degrees Celsius. According to atmospheric data, Titan may be the first planet in the solar system other than Earth where liquid may exist on the surface. Nitrogen, methane, and more complex hydrocarbons were also found, suggesting that primordial chemical processes would be conceivable on Titan. At 23:46 on November 12, 1980, Voyager 1 made its closest approach to Saturn at around 782,290 miles. After the near collision with Saturn, the spacecraft continued its mission, sending back invaluable data and images that continue to contribute to our understanding of the outer solar system and beyond. Voyager 1 set out on a course to leave the solar system at 523 million kilometers per year, 35 degrees to the north of the ecliptic plane, and roughly in the direction of the Sun's motion with respect to nearby stars. The spacecraft was not pointed towards Uranus and Neptune due to the unique need for the flyby of Titan. The first portrait of the solar system as viewed from outside was created on February 14, 1990, when Voyager 1's cameras were oriented backward and took roughly 60 pictures of the Sun and planets. The photos were captured at a distance of 3.7 billion miles, 6 billion kilometers, from the Sun. The pale blue dot image, made famous by Cornell University professor and Voyager scientific team member Carl Sagan, was created from a mosaic of those pictures. Despite the absence of Mercury and Mars, only Mars's dark side was visible to the cameras because Mercury and Mars were on the same side of the Sun. The two Voyager spacecraft took 67,000 photos before their cameras were switched off to save power and memory for the intergalactic voyage. After the last planetary encounter concluded in 1989, the Voyager 1 and 2 missions were declared part of the Voyager interstellar mission, formally launched on January 1, 1990. The new mission aimed to take NASA's investigation of the solar system beyond the region around the outer planets and even farther to the furthest points of the Sun's sphere of influence. Data collection on the boundary between the heliosphere, the area of space dominated by the magnetic field and solar wind of the Sun, and the interstellar medium was one of the specific objectives. When Voyager 1 passed Pioneer 10 on February 17, 1998, at a distance of 69 Australian dollars and 40 cents from the Sun, it took the title of the most distant human-made object in existence. On December 16, 2004, the scientist working on Voyager 1 stated that at 9:40, Voyager 1 had recorded high magnetic field intensity readings, suggesting that it had hit the termination shock and was now in the heliosheath. On August 25, 2012, the spacecraft finally left the heliosphere and became the first spacecraft to measure the interstellar environment. According to NASA, Voyager 1 detected significant changes in the environment, including an increase in charged particles and cosmic rays in June 2012. As a result, Voyager 1 became the first spacecraft to enter interstellar space at a distance of 121 astronomical units from the Sun. This signaled the inner boundary of the heliosphere. It was exceedingly fortunate that Voyager 1 did not rely on solar energy at this stage, since sunlight took more than 16 hours to reach the spacecraft. Voyager 1 was moving more than 10 miles per second away from the Sun. At this distance, Voyager 1 will take more than 73,000 years to travel at present speeds to Proxima Centauri, the nearest star to the Sun at a distance of 4.2 light-years. However, Voyager 1 is not traveling in the direction of Proxima Centauri. Instead, it is traveling in a different direction, making a straight line to the constellation Ophiuchus. According to a NASA study, mission control at Voyager 1 detected significant collisions with high-energy particles in 2012. These particles were once believed to be cosmic rays from supernova explosions far beyond the solar system. Along with this rise in high-energy particles, there was a sharp decline in low-energy particles from the Sun. According to researchers at Johns Hopkins University, these two events were sufficient to confirm that Voyager 1 had completely left the heliosphere and was now in interstellar space. The magnetic characteristics of this location looked to be different from what had been predicted. However, scientists soon saw something unexpected in the data. Dr. Ed Stone, the project scientist for the Voyager spacecraft at the California Institute of Technology, said in a statement, "Voyager has discovered a new region of the heliosphere which we had not realized was there. Apparently, we're still inside, but the magnetic field is now connected to the outside, so it's like a highway letting particles in and out. However, the magnetic field is now a part of the outside world, so it acts like a highway that allows particles to enter and exit." This unusual magnetic field phenomenon revealed that the area was 10 times stronger than experts first thought. It was anticipated to be the final obstacle to be cleared before Voyager 1 had left the solar system and entered interstellar space. Since Voyager 1 entered interstellar space in 2012, Scientists have been eagerly awaiting feedback from the spacecraft as no spacecraft has ever before left the heliosphere in the history of human space exploration. However, they were taken aback when, during one observation cycle, Voyager 1 started sending strange and, to be quite frank, terrifying data. Data from Voyager 1 seemed to be distorted in some way, suggesting that something or someone may be tampering with the spacecraft systems.